This archived clip from Make Live is brought to you by DigiKey.
Join us live every second and fourth Wednesday of the month.
Great, cool.
Are you ready to get to the metalworking?
Yeah, I think everyone's ready to talk about metalworking, and we have a great guest to start us off. He's the founder of the Madagascar Institute, and he's got a great new show coming out called Stuck with Hackett. Take a look.
This is Stuck with Hackett. What I need to do is mount a pulley to the handcart and belt it to the ATV's wheel. That'll put the motion next to the pump handle where I need it. There, I'll attach an arm with one end on the edge of the pulley wheel and the other end on the pump handle. So as the engine turns the ATV wheel, the belt turns the pulley, which will pump the cart and get it rolling. So I just need to figure out a way to transmit power from the wheel up to the bar. This is where the magic happens, where the rotary motion of the wheel turns into the linear motion of the pump bar. This hose seems like, yeah, it's about the right size. I'm not entirely confident in this hose. I feel like I'm using the large intestine of a diseased sea creature. It's pretty loose too. This tensioner should keep it nice and tight. Should be good. There are a lot of points in this transmission system where things can go wrong. But there's one major place where things can go horribly, horribly, horribly wrong. The linkage from rotary motion to linear motion. That's the point where things might fail, and as it fails, it's gonna basically shoot off shrapnel, throwing out pieces of metal and pieces of wood, quickly followed by pieces of blood and pieces of bone. So I think the next step is to just fire up the engine and see what happens. But first, I'm gonna disconnect the wheels in case the thing takes off from under me. Well, the engine works. I'm gonna see if I can get it to shift in the first without tearing my arm off. Belt looks okay for now. And it's running, excellent. You know, everything seems to be working perfectly. Wow, I hesitate to use the G word, but I think I might be a genius.
Cool, we've got the genius here.
It's true, I'm not a genius. If it's on TV, then it really happened.
Great, great.
All of this internet stuff, though, it's a lie.
Cool, well, thank you for being here, Hackett. You're gonna show us a little bit about welding. Can you tell me first, what's welding?
Okay, so welding is both in the specific sense of metalworking and in the vernacular sense. If you weld things, you take them and put them together. Mm-hmm. Think, okay, that's what I'm doing with a hot glue gun, that's what I'm doing when I'm sewing, that's what I'm doing when I'm soldering. The key difference is that when you're soldering or gluing, you are taking two things, your electronics component, your circuit board,
right,
and your solder, three different things, and they remain three different things.
Okay.
They're just stuck together. They're stuck together at a molecular level. That's what the cleaning and the flux and everything gives you. But when you are welding, you're actually combining those things together. You have two pieces of metal, if you're welding it together. If I was soldering them together, at the end I'd have two pieces of metal and solder, all stuck together, right?
Right.
But still three discrete things. With welding, I'm taking those two things and I'm taking the welding rod and it is becoming one thing.
Okay.
Three things enter, one thing leave.
Okay, wow, cool. So what kind of welding do you have set up here?
Okay, well with welding, welding can be used, and it is used as a concept for a lot of different things. You can weld plastics, you can probably weld cake together at the frosting level.
Okay,
you
sure,
mesh them
on
together.
the front, yeah.
This is electrical welding. It's used for welding of metals and plastics, but mostly for metal. It's what this basically does is you take the power of a short circuit, right? Mm-hmm. And people who do electronics components are probably familiar with this, or if you do auto work, you're familiar with it. When you're hooking something up to the battery and your connection isn't quite tight and it makes that spark.
Yeah, you have that arc that jumps through, yeah.
Yeah, and you see that arc and how it burns the component, and, you know, and
yeah,
you're screwed and you have to go get another one, or, you know, on the inside frame of your car, you see where it sparked out when you're putting the battery in.
Right.
That electrical short circuit, that arced connection has a ton of energy in it at a very specific point. A lot of heat. That's enough heat to melt the metal. So, what welding is doing is that basically this welder right here is just something that drops onto the floor, ruining everything.
I'm not sure what I can touch and what I can't touch, so
just step back a
little. I'll be over here. Yeah. You continue.
Remember, safety
First?
No, in the top 10 though.
Okay, top.
I think it's up to
safety's in
3.
the top 10. That's good to know.
So basically what this box is, this is a welder. It's a fine one. Does a bunch of different types of electrical welding. Basically all that is a transformer. It's taking, in the case of this one, it's taking house current, 115 volts, 60 hertz, I don't know, 10, 15 amps, and it's converting it to maybe 25, 30 volts DC at high amperage, like 70, 80 amps.
Oh, wow.
Short circuit from that is enough to melt metal.
Wow.
The power of a short circuit. So we have the ground, just ground, and all types. This box, I mean, you could do this all with a car battery. And doing some guest blogging on MakeZine this month, and I'll show how to weld with a car battery if you don't have fancy, expensive pieces of equipment. All basically the same. You have your ground, right? And you have your electrode. This type of welding is arc welding or stick welding. It is it's incredibly common. It holds our world together, like structural things, big sculptures, things that are outside. There are a bunch of different reasons that I'm not going to get into why it's good for some things and bad for other things. Okay. It's the simplest to show and the simplest for you to learn.
Ah, okay. So I'll be doing the welding here?
You will be doing the welding, so you can step up closely then.
Okay.
So I have my ground, I have my electrode. This is just tied in to one lead of the DC current. This is tied into the other lead of the DC current. If I was to stick these things together, the whole welder would melt and be destroyed, but become one.
Oh,
weld itself, which we don't want. So to weld, you strike an arc, you create that electrical short circuit, the arc jumps, super high heat, it melts the base metal, and it melts the filler rod. This filler rod is basically a rod of pretty precisely formulated steel, just so you get quality control, things like that. And it's surrounded by a ceramic flux.
Now, I know that with the electronic soldering, there's flux inside. There's a core that's flux. Is this the same? Does it serve the same purpose, or?
No, with as far as I know, and I'm sure some know-it-all on the internet will correct me if I'm wrong.
I'm sure someone in the chat will know.
Yeah. So this is what I say. I say that flux, when used in soldering, if it's used in plumbing soldering or electronic soldering, basically it's used to clean the base metal or the two things that you're soldering together, right? Down to the molecular level. It etches in a little and it gets it so that solder, so that hot glue can get in as tightly as possible. You have as good a conductive seal as possible. Right. This sort of flux, what this does is it basically evaporates and boils away.
Oh, wow.
Why does it do that? Well, I'm welding, if you're welding any metal, if you heat any metal up, it wants to react with oxygen, atmospheric oxygen. It's the same thing as rusting, oxidation. Rusting takes a period of time for something to go from nice and shiny to all rusted. As with many chemical reactions, you increase the temperature, you increase the rate of reaction. I am heating these metals up hot enough to, again, just a ballpark, I'd say 30 times the temperature of the surface of the sun. And at that sort of temperature, chemical reaction happens quickly, oxidize quickly. So what this flux does, it boils away, shoves all the oxygen out, leaves a ceramic coating, make sure the metal's okay. So less talk, more weld. Okay, let's weld then, yeah. You need safety gear, and by you, I mean you need safety gear. Okay. I choose to
here we go.
deal without safety gear. I don't know if you can get this on yourself.
Can you give me a hand
Perhaps
here? Let's see. Okay.
Why do you need safety gear? Because
it goes like this. Wait.
When you're welding, that electrical arc is dumping out tons and tons of UV. In addition to the physical heat that it's putting into the metal, it's also putting out heat that you can't see, radiation that you can't see. That UV will burn your eyes, it'll burn your skin. It's exactly like, you know, when you sit out and stare at the sun for hours and hours and hours at a time? And then it burns your eyes? Same thing, but much quicker. You'll get a retinal burn, you'll get nasty sunburn on the exposed part of your body. And just from like leaving a button open, I get these nasty little burns right here in between the bottom of the helmet.
Oh, no kidding.
Top of my shirt.
Oh, wow.
Yeah. It's excruciatingly painful. What's also lovely is if you're welding in a sleeveless shirt, you get the armpit burn.
Oh, okay.
You don't know what
get the sun under the, yeah, that's cool.
discomfort is.
Why it's only a half coat that Matt's wearing.
Why is this only half?
Because it looks more Ren Fair that way. No. It's only a half coat because he's already covered. He's already wearing a shirt. A fine shirt it is. And he doesn't need covering down there. Up here, this is basically meant for people who are wearing short sleeves, or you're showing a little skin up here. Also, most of the action that you're doing, most of the splattering and stuff, if you're down here welding, it's going to hit you up on your sleeves.
Okay.
Right? So those are covered in leather.
Okay.
Your hands are covered with gloves. It's a minimum of protection. They also make them so that they're backless. On this one, you can snap in an apron that'll cover the whole front.
Okay, cool. And what about the helmet here? Is this, I have to turn this one on, is that the case?
Well, in that case, I'm wearing a helmet that's just dark glass, dark plastic, what have you. It blocks a UV, but makes it so I can't see anything until I have the welding arc to see by.
Okay.
You are wearing a fancier helmet, because you are a fancier person than me. You get the protection, you get the fancy helmet.
Okay.
That's an auto dark helmet. An auto dark, it's an LCD, right?
Okay.
And it, you know, an LCD is see-through unless you switch it on.
Right.
So that one's see-through. It's still like sunglass shade, so you can see what's going on in front of you. You know, you can set up, you can do your welding. As soon as the bright light happens, as soon as you turn and look at the sun, as soon as you get the bright spark from welding, as soon as you get any of those things,
Right.
it flashes on and it opaques the LCD.
Okay,
So
cool.
it's an auto dark helmet.
Cool.
This
So,
is an
I don't know
always
if you
dark
can see, it's got inside here, it's got like a on-off switch in there. There we go. Cool. Interesting. That's cool. All right.
They're great. They're a great purchase. I personally don't use them because I don't trust them, because they
Okay.
get banged around a little and sensitive electronics go bad.
Sure.
Also, they're a lot more expensive than
Okay.
what I'm
Okay,
used to.
cool. So let's, I guess, weld.
Okay. So I'm going to do this once, and then you're going to do it.
Okay.
So watch carefully.
Okay.
I have my ground. I'm grounded to the metal. I've got the other end, arc, going through the rod. With stick welding, arc welding, interchangeable terms, you strike an arc. It's like striking a match, and then you'll be throwing the hot death of molten metal in between. You make a puddle by pulling it back so that it throws its heat and it melts the base metal, and then you need to fill the puddle by shoving the rod in. So back, forward, back, forward.
Okay.
Make a puddle, move a puddle. It's the basis of all welding. And in this case, what people often say is to imagine making a stack of dimes.
Okay.
So circles that are half overlaying each other,
Okay.
and that's your weld. I'm gonna do it a little, and then you're gonna do it.
All right.
Okay, so you shouldn't stare at this bright light. What I like to do in the Madagascar shop is when we get ready to weld, we'll just say, hey, whose keys are these? So I'm striking my arc, I'm pulling it back, melting, pushing it in, filling. Back melting, in filling. Okay?
Okay.
And you see sparks and hot stuff goes flying all over the place.
Cool.
If you're an experienced metal worker or an especially stupid metal worker, you end up with, you just get enough burn scars covering your hands, so you don't really feel it anymore.
Okay.
So now it just looks like a lump of, I don't know, like an old dried piece of gum. That's a ceramic flux that I was talking about.
Okay.
So we need to chip with a chip hammer, but you can use any hammer. You can use your multi-tool to bang away at it. You can use a rock, whatever. Need to get the flux away. And I'm gonna start chipping at this. And our eyes are a tiny bit of the surface area here. But
Put my glasses on here.
I'm gonna do the Madagascar squint, where you leave one eye closed, so that if I do get something, instead of ruining both eyes, I'll use my backup eye. All right, so we chip. All right.
Can we show them what that looks like? Just hold it up to the camera there. Oh, there you go.
So I've chipped away the ceramic flux, and now I just hit it with the wire brush. And voila, a weld bead. See, the bead is right there. This stuff over here is just splatter. Like, did you see how when I was doing it,
Yeah.
there's splatter stuff
Right.
all over the place? That's just little bits of metal. They're not really attached. If I was to hit that with a grinder or keep scrubbing at it with a wire brush, those would come off.
Okay.
We have a question from the chat about pushing or pulling the the welding electrode?
That, it's a good question, and it's
What
kind
was the
of.
question? Pushing or pulling?
Yeah, were you pushing or were you pulling? And I know that there's different kinds, so.
I was pushing on that. Pushing and pulling, that refers broadly to the type of hand motion, basically the direction in which you're moving the puddle.
Okay.
Are you pushing the puddle or are you pulling the
Oh,
puddle?
I see. I see.
Whether or not you push or pull, it depends on a bunch of things. It depends on the position that you're in when you're welding. It depends on what type of rod you're using. Welding rods have a four number code. Like these, I think, are 6013. One of them refers to the type of metal that you're welding. Another refers to the positions in which you can weld. Blah, blah, technical, ask the internet. It will tell you all you need to know. Okay, so basically that's it.
Okay.
You do it.
Now, how do I know that this helmet, how do I trust that this is on? It didn't seem like it was flipping on before.
You should trust no one. The way to trust with an auto dark helmet is that you hold it up to the light and you hit the button. See, it flashed, went dark.
Okay.
Now we know it's on.
I have another question. Hackett, how did you learn how to weld?
I saw Doyle welding on TV once, and that taught me all I needed to know.
Doyle was on our show last time.
Yeah, see,
Oh.
Doyle.
And so all of you now can weld by watching Hackett.
No. If you saw Doyle welding, you would learn. He,
So why didn't we get Doyle?
it spreads.
Just kidding.
Guy's huge.
All right. Okay.
You ready? Ready?
I guess so. All right. So.
What could possibly go wrong? Lots of things.
Yeah. Yeah.
Yeah.
So where
might
should
die.
True. Okay. I'm actually very nervous about this. So
You should be.
here we go.
It's the fourth leading cause of death.
And yes, and if something goes wrong, at least it'll be all recorded.
I have a fire extinguisher.
Okay. We have a fire extinguisher, so at least you could put the fire out. But all right, here we go. So I'm gonna strike.
You're going to strike it like striking a match.
Okay.
And then you pull away a little, let's say between 1/8 and 1/4 of an inch. And then you heat it, fill it, heat it, fill it,
Okay.
heat it, fill it. A difficult thing about arc welding as opposed to other types of welding is that your electrode, the thing with which you are holding the power, gets consumed as you're working. So you think, okay, I've got the perfect hand position, I'm moving along, and then all of a sudden it stops. Why does it stop? Because you've consumed the electrode. You have to keep moving that hand in.
Okay.
But it's a skill set that transfers well.
It's like when I'm soldering electronics, I'm moving the solder in as I go.
Now
Yeah.
we're seeing a lot of encouragement for you in the chat, so I
Thank
don't
you
think you have
guys.
anything to
Thank
be
you.
afraid of.
Okay. You'll witness hopefully me get out of this alive. Here we go.
Yeah.
All right.
So remember to yell, "Hey, look!"
Hey, look. Okay, I'm ready to strike.
Yep.
Okay. Can I just put this up here like this? Hold it steady.
Yep. I'm holding it steady for you. Don't
Okay.
weld my hand.
Okay. Here we go. Okay.
There you go.
Whoa.
Okay, that's good. Stop.
Okay, how was that?
It looks good, but see, that's the thing about stick welding, especially if you're not experienced with it. It'll look fine, but chip away.
Okay.
Let's see it. Let's take a look at the weld before you
Oh
chip
yeah,
it.
let's
Okay.
see. Now, can I just put this down here? Or is that gonna?
Here, just have it for me.
Okay.
You could set it down on the table, but then when you put the other thing down, you end up electrifying the table.
Okay.
So you see, that's Matt's
So
weld
that's the
right there.
ceramic is coating it here. That's
Right.
Okay.
That's a flux. So let's put that down and chip.
okay.
Remember, good thing about auto dark helmets is that you can just flip that down and use that when you
Oh
chip.
yeah, because it's not dark. So.
Right. I'll stand over here and squint.
It's actually really hard to see. So okay.
And if you can, use a spring action in the hammer, just thwap,
Oh.
thwap. You know what I mean? Oh, look at that. That was great. Like all of the ceramic just came off in one shot, basically, which
Is this
bodes
hot?
well for
It's
your
hot,
weld.
right?
Yeah, it's hot.
Let's see. Can we
So
get
you
that
see-
close in there to see that? So how would what would be my letter grade here on my first weld job?
I'd
Here, look, I
say.
dropped down. Come in a little closer.
What, am I?
Oh, and
Oh, brush. Yeah.
yeah, we brush it just so we can see a little.
Everyone in the in the chat's very proud of you, Matt, but I'm curious too. What's your letter grade?
That's good.
Yeah,
That's
what did
really
I
good.
get?
But look at that. That looks like a weld, doesn't it?
Yeah, it does actually.
And you've had good penetration. Penetration is how deeply you get into the metal. That's a good weld. That's like a solid B plus. But for the curve of never having welded before, that's like an A.
Hey, great. I'll take it.
Yeah.
I'll take it. Cool. So thank you for showing me all this stuff. I want to hear a little bit about Madagascar Institute and what that's all about.
So Madagascar Institute is an art combine. It's not a collective. Collectives are for hippies. They're for people talking about each other's feelings and things like that. Consensus. We're not into that. Before all of the, in the last few years, hacker spaces have been spreading. You've documented a bunch of them, and like the DIY movement has been spreading and spreading. Make Magazine has been a great part of that. Basically, helping people make the things and like go out and create things rather than just consume things. Right. Madagascar Institute is an organization. We do big art, we do big events, and we have a shop. And the point of the shop is that there are enough people, there's enough resources, there's enough tools, there's enough knowledge that the only thing between you having a great idea and your great idea being reality is your own lazy ass.
Okay.
Everything that you need to do the big thing, to build the big thing, to do the big performance, to make the costumes, to learn to weld, et cetera, et cetera, et cetera, that's all there in one place.
Cool. That's great. And so can you talk a little bit about what you've done at Maker Faire, or what kind of big things you've done?
We do two basic themes of things. We make big things, actual physical things. For the most part, it's been carnival rides, because carnival rides are fun.
Oh, here we have the jet ponies
Yeah.
from Maker Faire.
So carnival rides, jet-powered carnival rides, what can be better? Who are those people on the ride?
Do you know who that was? Yeah, I don't know.
No, they look vaguely familiar. So we make things like jet ponies, jet-powered carnival ride, because carnival rides are fun, it's interesting engineering, it's reuse of stuff that we found in the trash, but there's also a performative aspect to it, which is the other stuff that we do. You know, so and you just get into the motions, we're like a pit crew, it's like a little dance that we do when we set up to get the jets running. Another thing that we did at Maker Faire was the chariot races, and with that, it wasn't just the boys with toys with big machines. We also had some sex and some violence and some splendor, all of those things. You
Cool.
know? It makes for better art, I think.
Yeah, great, cool. So this is from Maker Faire, New York, right? The jet
Yes.
ponies? Cool.
Yes.
Now, I want to also hear about Stuck with Hackett.
It's a TV show.
Okay.
I don't have a TV. Do you have a TV?
I do have a TV, yeah.
have cable?
I do. I'll be watching.
Oh, wow. Cool.
I'll be watching.
All right, we have a fan.
Yes.
It's on the Science Channel. It's interesting. It's basically what I kind of do in life. You know, just like you are, if you're in a survivor situation, let's say, you shouldn't have to be able, you don't have to run around and, like, let's say the zombie apocalypse happened tomorrow.
Okay.
There is no reason at all to start drinking your own urine or eating bugs.
Okay.
Because there is enough lying around. There's enough waste. There's enough just stuff, you know, lying around. For the water, you just get the water from the toilet tanks of all the people who've gone zombie.
Right.
Food, just cans of cream corn and pumpkin pie filling that, you know, no one ever wants, but everyone has. But what about the finer things in life?
Okay. Like,
You know, air conditioning if it's hot, a hot tub if it's cold, electricity,
right.
laundry.
So what would you do about air conditioning? What?
Well, in the pilot, I made air conditioning using, and I guess what the show tries to do, or what I hope the show tries to do, haven't seen the edits yet, by the way, just the raw footage, is take the base scientific principles, basic things that you know or that you should know, and how do you apply them using whatever you find lying around. Let's say you have a budget of $0,
Right.
right? And you want to make air conditioning. It's like, okay, what things cause cooling? For the pilot, we use the idea of, well, there's evaporative cooling. There's that, you know, the energy that it takes for heat to go into water, et cetera, et cetera, et cetera. So if you have a dry situation, if you moisturize the air, a lot of that heat goes into the water, you have cooling. It's
Right.
a swamp cooler. It's a basic concept they use in parts of the desert.
Cool. Cool. So I don't have the date handy. What is it? When's the premiere? Is September? August 18th?
August 18th at 10:30 p.m. on the Science Channel.
Yes.
August 18th, 10:30 p.m. on the Science Channel, Stuck with Hackett. Thank you for being here. Thank you for showing me how to weld. I hope to learn a little bit more about it.